The derivative rules for sum and difference were very easy. The derivatives of a sum are just equal to the sum of the derivatives. However, the product rule is not that easy. Let me explain. Let's say I had f of x equals x to the fourth and g of x equals x squared. If I wanted to find the derivative of f times g of x, if I made the mistake of doing this, what I would get is this. The two derivatives multiplied together, and when I finish multiplying this out, I would get 8x to the fourth. Let's, however, go ahead and multiply these two together. F of x times g of x is simply x to the sixth. So this should be 6 times x to the fifth, which is certainly not equal to 8x to the fourth. So we can't just take the product of the derivatives. I'm going to give you what the product rule is, and then I'm going to go ahead and prove it. The product rule of the derivative of f of x times g of x is equal to the derivative of f of x dx times g of x plus f of x times the derivative of g of x dx. Let's go ahead and prove this by the derivative definition. So here we've applied the definition of the derivative. Now I'm going to do basically a trick that I'm going to do just because I know it gets us where we need to get. I'm going to add these two terms, and I can do that because when I add those together they add to 0, and I can add 0 to anything. So if I do that and rearrange things a little bit, I'll get this. If I split these up, I get this. And then I see in both of these terms, in both of these numerators, I can pull something out. In my first term, I can pull out that g of x plus h. And with the second term, I can pull out an f of x. If I let h approach 0, then this part here, well, that's simply the derivative of f of x. G of x plus h, as h goes to 0, well, that's simply g of x. And then that f of x as h approaches 0, that's simply f of x. And the rest of this, well, that's just the derivative of g of x. And that's how I get my general product rule. Again, I'm not expecting you to recreate this proof on a test, but it's nice to know where it comes from. Let's do a few examples. All right, the one on the left-hand side, I'm going to let x squared be f of x, and I'm going to call 2x squared plus 1 g of x. Off to the side, I find that f prime of x is simply equal to 2x, that's using the power rule. G prime of x is equal to 2 times 1/2 x to the negative 1 plus 0. I'll go ahead and add the plus 0. That's using the constant multiple rule, the power rule, and the constant rule. Once I have that, I can just go ahead and plug in everything into my product rule, and I take f prime of x, multiply it by g of x, and then I add to that f of x times g prime of x. I can go ahead and multiply this out. I'll get 4x to the 3/2 plus 2x plus x to the 3/2, and that simplifies to this. All right, my second one, I'm going to let my x squared be my f of x, and g of x will be e to the x. Again, off to the side, f prime of x is again equal to 2x. G prime of x is just e to the x because e to the x is the greatest derivative ever. So if I go ahead and use the product rule, I'll have f prime of x times g of x plus f of x times g prime of x. If I wanted to, I could factor out the e to the x and get this as my final answer. Well, actually, that's not completely factored, is it? I could even pull out an extra x. That's in complete factored form. The quotient rule I'm not going to prove. You're just going to either take my word for it or look up somewhere else on the internet how the product rule is derived from the derivative definition. It's g times f prime of x minus f of x times g prime of x divided by g of x all squared. Again, this is for the derivative of f of x divided by g of x. Some people have a shorthand way of memorizing this. They call f of x high, g of x low, and you can say low d high minus high d low divided by low squared. However you need to memorize it, I don't care, but you do need to know this. Let's do an example or two of this. All right, if I have the derivative with respect to x of x squared plus 3x plus 4 divided by the quantity x squared minus 1, the first thing I'm going to do is say that f prime of x is 2x plus 3, g prime of x is 2x. So this derivative is f prime of x times g of x minus f of x times g prime of x. And I'm then going to square the g of x and put it in the denominator. We generally aren't going to be expanding the denominator, but I am going to clean up my numerator. When you multiply out the numerator, remember the whole second term is subtracted. So put a negative sign out front and then go back and distribute the subtraction. And when I go ahead and simplify that, this is my final answer. Now what do we do with the second example? I haven't yet talked about how to deal with e to the something other than x. So the first thing I'm going to do is rewrite this as 1 over e to the x. Once I do that, I realize happily that f prime of x, that's just equal to 0, and g prime of x, again, is just e to the x. So when I use my quotient rule in this case, I'll have 0 minus 1 times e to the x divided by e to the x squared. I'll get negative e to the x divided by e to the 2x, which simplifies to negative 1 over e to the x, or simply negative e to the negative x. I want to bring up the power rule again. I do want to say that this power rule, even if n is negative. So let's say I had the following. If I had the derivative of 5 divided by x to the 5th, I could in fact use the quotient rule. Or I could simply rewrite this as 5 times x to the negative 5 power. Once I do that, I can then use my constant multiple rule to pull out that 5, and then just use my power rule. And I go from negative 5 to negative 6, and this whole thing is negative 25 divided by x to the 6th. So I could have used the quotient rule, but I could save some time and just rewrite this as a negative exponent and use the general power rule. I can also use a trick here. If I have the derivative with respect to x of 3x to the 4th minus 4 divided by x cubed, I can certainly use the quotient rule, or I could recognize that I could split this up into 2 separate fractions and then use the sum rule and rewritten 4 over x cubed as 4 times x to the negative 3, and I simply get 3 plus 12x to the negative 4. Again, it would not be wrong if you did it using the quotient rule, but the quotient rule can get kind of messy looking, so always look to see if you can simplify things so you can use one of the simpler rules. Let's do one last example where we have to use a bunch of different rules. When I look at this, I don't see any easy way to simplify this, so I'm pretty sure I'm going to have to use the quotient rule. I'm going to let f of x be 4x e to the x, and g of x is equal to x squared plus 1. So now I need to find f prime of x. Well, in order to find f prime of x, I'm going to have to use the product rule. So let's give myself a little more space. I'm going to call 4x my f of x, and I'm actually going to call it f1 of x because I already have an f of x. Once you start doing rules within rules, it can get a little bit hairy. So I'm going to call this f1 of x and g1 of x. So if I want to use the product rule, I'm going to take f prime of x, which is simply equal to 4, times g of x, and add to that f1 of x times the derivative of g to the x, which is just e to the x. So that's my derivative of f of x. G of x is easier. If I want to find g prime of x, that's simply equal to 2x. And I'll specifically say I was using the sum rule and the constant rule and the product rule. And now that derivative, clean up my question there, and now this derivative is simply equal to, I'm going to write it out first, f prime of x times g of x minus f of x times g prime of x divided by g of x squared. So this is 4e to the x plus 4x e to the x in parentheses times x squared plus 1 minus f of x times g prime of x. And this will all be divided by g of x squared. And hopefully you'll take my word for it that this works out to be the following. And that's my final answer.